Hey everyone, Mr. Halk here. In today's video, we're going to be looking at forces on inclined planes. Let's go ahead and get started. By the end of this lesson, we should be able to use vectors to represent and solve problems involving forces in inclined planes. So, problems focused on inclined planes can be represented and solved by using vectors to represent the components of the forces. Let's take a quick look at Newton's third law of motion, which states that if an object A exerts a force on object B, then object B must exert a force of equal magnitude but opposite direction on object A. So here we have a force diagram. We have some object that has a weight. Here we're going to define weight as the mass of the object times the gravity, or mg. So weight equals mass times gravity. We're going to be presenting all of our problems with the weight being in pounds here in pre-calculus. So we don't need to worry about taking a mass in kilograms and multiplying it by 9.8 meters per second squared. We're just going to represent our weight, our mg, in pounds. Okay, so if we have an object on an inclined plane, then the object has a weight that is perpendicular to the surface of the Earth. The object also has a perpendicular force, a force that's perpendicular to the plane itself. Perpendicular meaning it makes a 90-degree angle between the object and the plane. And the weight also has a parallel force that is going down the plane with. Now, according to Newton's third law, this parallel force will also have a parallel force acting in this direction, equal to the parallel force acting in this direction. And also this perpendicular force between the box and the plane, there will be another force of equal magnitude acting in this direction as well. So the parallel force of the object on the inclined plane is represented by a vector parallel to the inclined plane itself, of course. The parallel force is found by multiplying the weight of the object by the sine of the inclined angle, or the parallel force is the weight times the sine of theta. Theta being right here, this angle here. Let me go ahead and label that with a theta. Okay. The perpendicular force acts at a right angle to the parallel force. The perpendicular force is found by multiplying the weight of the object by the cosine of the inclined angle, or the perpendicular force is the weight times the cosine of theta. So how are we getting, parallel force is the weight times the sine of theta, and how are we getting perpendicular force is weight times the cosine of theta? Well, let's take a closer look at this here. So we have our weight, which is right here, mg, and we know that this weight, terrible, I want it perfect. Here we go. Perpendicular to the Earth, but we also know that this weight, there's a force perpendicular to the plane. And we also know there's a parallel force right here. Now, this parallel force, I'm going to go ahead and take it and bring it over here as well. Okay? So we have this angle theta here. And it turns out that the angle theta right here is also right here. And you might be asking yourself, well, why is this the case? And it's all because of the fact of all these different 90-degree angles. So we have a 90-degree angle right here created from the weight of the object being perpendicular to the Earth, but we also have a 90-degree angle right here, okay? So let's say, for example, this was 30 degrees. Well, if this is 30 degrees and we have a 90-degree angle right here, then that means this must be 60 degrees. But if this is 60 degrees and we have this 90-degree angle because the weight of the object, or we have a perpendicular force right here between the object and the plane. So if this is 90-degree angles and we just established this was 60-degree angles, then this angle theta must be 30 degrees. Let me write all that in here just so it is a little more visible. So we're just assuming here. Let's give an example. Maybe this is 30 degrees. Well, if this is 30 degrees and we have our 90-degree angle right here, then this little piece right here would be 60 degrees. But we already stated that we had this perpendicular force between the object and the plane itself, meaning that this is 90 degrees. Well, if this chunk of the 90 degrees is 60 degrees, then this piece right here would have to be 30 as well. So we can see that, whatever this angle theta is going to be, we would also have right there, okay? So let me get rid of those extra degrees right there, okay? So we've established that this is theta, same as this angle right here. So what we would be looking for is, well, this is the perpendicular force, we'll call it F perpendicular. This is the parallel force, which is also right here, F parallel. Here's our 90-degree angle, and we've already established that this leg of the triangle, which is the hypotenuse, is the weight, okay? Force due to the weight. So the question is, how would we determine equations for the perpendicular force and the parallel force? Well, we can see right here, because this is a right triangle, that the sine of theta should be the parallel force divided by the weight. So sine of theta would be the parallel force divided by the weight. Well, if you just multiply the weight, mg, on both sides, you get that the parallel force is mg times the sine of theta. Same thing for the perpendicular force right here. Well, we can see that's the adjacent leg with respect to this angle theta. Well, we know that, cosine of theta would be the adjacent leg perpendicular force divided by the hypotenuse, mg. So cosine of theta would equal the perpendicular force divided by the hypotenuse, which in this case is the weight, m times g. Well, again, multiply mg on both sides, and we get perpendicular force is equal to mg times the cosine of theta. So that's where those equations that we have highlighted are coming from right here. So what you need to know is that anytime you're looking for a parallel force, either here or the equal but opposite direction parallel force here, you're going to be using the weight times the sine of theta. Anytime you're looking for the perpendicular force, or the force that the object is putting onto the plane, or its equal but opposite force, which in physics you call the normal force, we'd be using perpendicular force as weight times the cosine of theta. Okay, let's try some practice problems here. So a 200-pound box lies on a ramp that makes an angle of 24 degrees with the horizontal. A rope is tied to the box from a post at the top of the ramp to keep it in position. Ignoring friction, how much force is being exerted on the rope by the box? So we are looking for the parallel force. Okay, we want to know how much force is being exerted on the rope by the box. So again, I'm going to make note of that. Looking for parallel force. We know that the parallel force is the weight, mg, times the sine of theta. We also know that the weight is 200 pounds, and we know that the angle is 24 degrees. So this is going to be 200 times the sine of 24 degrees, which, throwing this into our calculator, making sure that your calculator is set to degrees, since our angle is in degrees, we would get approximately 81.35 pounds. Okay, so that would be the force of the force being exerted on the rope by the box, or the parallel force. Let's try a couple more examples, and notice I've already got the diagram drawn in here to save us a little bit of time. So in the next example, a sled on an inclined plane weighs 500 pounds, and the plane makes an angle of 50 degrees with the horizontal. So 500-pound sled, 50 degrees with the horizontal. What force perpendicular to the plane is exerted on the plane by the sled? So again, we are looking for the force perpendicular to the plane exerted on the plane by the sled. So we are looking for the perpendicular force. And we know that the perpendicular force is equal to the weight mg times the cosine of the angle. Well, we know that the weight is 500 pounds, and we're going to multiply it times the cosine of 50 degrees. And throwing this into our calculator, again, making sure our calculator is in degrees, we're going to get 321.39 pounds. So that is the force that is being exerted on the plane by the sled, or this perpendicular force right here. In our next example, if a force of 25 pounds is required to move an 80-pound sled up a hill, then what angle does the hill make with the horizontal? So notice in this example, again, we have the weight of the object, 80 pounds. That's going to be our mg. So I'm going to go ahead and highlight that. But notice that it's saying we have a force of 25 pounds is required to start moving this sled up the hill. So that is our parallel force. We have our parallel force being applied to the box moving on this inclined plane of 25 pounds. So I'm going to go ahead and write down some of the stuff we have here. We have the parallel force, which is 25 pounds. And we have the weight of the object, which is 80 pounds. And we are trying to find the angle. We're trying to find the angle the hill makes with the horizontal. And I've got that labeled right here as theta. So we know that parallel force is equal to the weight of the object, mg, times sine of theta. We know that the weight of the object is 25 pounds, so I'm going to substitute, we know the parallel force is 25 pounds, so I'm going to substitute the parallel force with 25 pounds. And we know that the weight of the object is 80 pounds, so I'm going to substitute mg with 80. All right, so 25 equals 80 times the sine of theta. Well, let's go ahead and divide both sides by 80. This would give us the sine of theta is equal to 25 over 80. And we know that if we want to get the angle, we're going to need to take the inverse sine of both sides. So this is going to tell us that theta equals the inverse sine of 25 over 80. And using our calculator, again set to degrees, this would tell us that theta is approximately equal to 18.21 degrees. All right, so that the angle that the hill makes with the horizontal is 18.21 degrees in this example. In our last example here in our notes, a weight of 15 pounds is placed on a smooth plane, inclined at an angle of 24 degrees. So 15 pounds is the weight, angle of 24 degrees with the horizontal. What force is pushing along the plane will just prevent the weight from slipping. So pushing along the plane, that's the parallel force. So we are looking for the parallel force. And let's see, we know that the parallel force is equal to the weight, mg, times the sine of theta. We know that the weight, mg, is 15. We know the sine of theta is 24 degrees. 15 times the sine of 24 degrees, throw that into the calculator, you're going to get 6.1 pounds.